We have the battery completely assembled, and today we're going to do some capacity testing. Let's get started. What's up, everybody? Welcome to Freely Roaming. My name is Dan. Thanks for coming back to our DIY lithium iron phosphate battery build video. In the last two episodes of this series, you saw all the components that I'm using to do this battery, and also in the second one you saw me build the battery enclosure, create my own bus bars out of copper pipe, and also assemble all the parts. In the last one there was one thing that I was still missing, and I finally got it today. I was able to also get this battery fully charged. So now we are completely ready to go. I'm going to install this one last part, and then we're going to try to put a load on it to see how long this battery will last. I'm also going to show you what the interface of the Bluetooth app looks like in the Victron Smart Shunt. Okay, here we have the battery, as you saw at the end of the last video on this battery build. And a couple of things I did since I wrapped up that video is I just tidied up some of the wires. I put some electrical tape around it so it kind of gets them out of the way, so it's easier to see what's going on. I've also added some high temperature tape on top of this terminal, on top of these terminals, and also on this active cell balancer, for no other reason besides just in case this VHB tape comes loose for any reason. Maybe it gets too hot, the glue starts to melt, kind of falls over. I don't want things to short out, so I've got this thing secured here pretty good with some tape, and also cover this up with double-sided or with high temperature tape so it prevents shorting. I may do it to these terminals too, but I'm going to wait until I'm completely done doing these additional wiring that I'm going to do. Specifically, I'm going to do a couple of these connectors that I got. These are the connectors that I've been waiting for. These little 5-pin connectors that are used for RC batteries. It's designed to go into my capacity controller like this. Plugs into the side of the capacity controller like this, and then these 5 leads go to these 5 extra wires that I've got hooked up to my battery pack. They were just kind of bundled up and taped together, if you recall from the last video. Today I'm going to wire up these leads so one can go to this capacity controller so I can always see voltage numbers at a glance, and also individual cell voltage, and also the delta between the high and the low of all the cells. So once this is connected, I'll have an extra one. This would just be kind of hanging out loose in case I ever needed to use another device for any kind of diagnostics or anything. So this would just be an extra one that gets kind of tucked in here somewhere safely for anything I may use in the future. So before I go through all that, let me show you what this Victron app looks like. Okay, so I make sure Bluetooth is on. I go to VictronConnect, and right away inside the app I can see my shunt, which is this guy right here, and my battery sense, which is this guy right here. Somebody left a comment which I thought was helpful, and something that I should have mentioned is that if you buy the Victron Smart Shunt, you have the option to buy a temperature probe that goes into one of these ports, and that'll go directly to where the battery terminal is, and that would actually allow the Victron Smart Shunt to also act as a voltage and temperature sensor. Now, the question to me was, why didn't I use that instead of this Victron battery sense? And the reason is I had already bought this battery sense before I got the shunt, because my original plan was to use a different shunt. And the temperature and voltage probe from Victron specifically works with Victron shunts, either the BMV 712 model, or this one works with it as well. Now, if you go that route, you will not be able to use a different shunt, obviously. And secondarily, you will lose the ability to monitor the voltage of another auxiliary battery, which is what this is initially intended for. But if that's not a problem, and you want to be able to save, I think you save about 20 bucks, because I think the temperature probe's 20, and then this temperature or this battery sense from Victron is 40 bucks. So you can save a little bit of money. But for me, I already had the battery sense. And another reason why it wouldn't have worked for me anyways is for some reason the Amazon stores would not ship the temperature probe to me at this address in Croatia. But they are able to ship the Smart Shunt and the battery sense. So I'm not really sure why that is. It just turned out that way for me. So if you're considering going with this route, think about that as an option. If you don't want the battery sense, you can just get the temperature probe directly. I'll put a link to that in the description below as well. Okay, so back to this. The Victron Smart Shunt. So I'll tap on that. You can see here, we're at 100%. And I've been charging it for the last 2 days. And once it's fully charged, I reset the historical data. So now everything's zeroed out. I've not charged or discharged any further from this battery pack since it was fully charged. So it's ready to go. As soon as I do some more wiring for this capacity monitor, I'll be able to put a load on it and just leave it, walk away. And with this, I will be able to see my status, the voltage, the current voltage, which is 13.72. In 13.72, that means each cell is at about 3.43. I believe 3.6 is the fully charged battery voltage, and that'll give me 14.4 volts. But 3.43, which is what I have right now, about the average between these 4 cells, leveled out voltage for these at a near 100% capacity. I used my NoCo Genius G7200 battery charger to charge this pack. It has a lithium mode, which is what I use. It's compatible with lithium iron phosphate. It technically charges it at 7 amps at 14.2 volts. I'm not exactly sure what the different charge phases are for that particular device. That is a similar charger that I have in the van as well. So by using that to charge it, lets me know that if I use my short plug to charge this, when this is installed in the van, it will also work. So back to the shunt. Once I put a load on it, I'll be able to see how much current it's drawing in amps, and also I'll be able to see it in watts as well. And it'll keep a tally of amp hours consumed down to the 10th digit. I plan to use a couple of incandescent light bulbs running at about 75 watts. So it should put a load about 150 watts on it. I don't have a bigger inverter to use this with. My inverter can only do 300 watts. I may, if I have the extra capacity, to add another light or another fan just to get the wattage consumption up higher. And once I get that running and it's starting to consume power, I'll be able to see under the time remaining just how much time this battery has left. Because when you go into the Smart Shunt, you go into the settings, you click on battery, you can set the battery capacity. I have the battery capacity set at 280 amp hours, which is what this battery is. I'm not sure exactly when the BMS will cut the current off, so I'm just going to let it run until it completely shuts off. It will probably be based on how this BMS is programmed, at what voltage this is designed to shut it off. And then from that, we'll be able to come back and see just exactly how many watt hours or amp hours it consumed through the Smart Shunt. Okay, so before we get started doing some capacity testing, let me go ahead and wire up this capacity controller. All right, so I've got these 2 leads soldered on to all these wires. I did sort of, I don't know, kind of an ugly job bundling it up with some electrical tape. At least they're kind of out of the way, they're sort of organized. So like I said, one of these is going to go to the capacity controller, and then the other one just going to be a spare. I figured if I'm going to wire these up, I may as well do an extra one just in case there's something else that I want to do with it later. So let's just see how this works. You want to make sure the red is on top, and then you want to plug it into the first 5 pins of this. That is in the LiPo mode, so we don't want that. We want to go to lithium iron phosphate, and right away you can see the battery capacity jumps up to 91%. I'm not exactly sure how this is programmed. Whatever data is programmed in here is taking 13.69 volts as 91% capacity, which might be true. If we're basing it on 14.4 as full capacity, I'm not using this as my battery monitor. I'm using my shunt to tell me how much capacity I have. So this is just a reference, to see where you're at. So let's see the different modes. Actually, first let's see the cells. Individual cells, I can toggle through them. Cell number 1, 3.426, 2, 3.425, cell 3, 3.421, cell 4, 3.426. And overall pack voltage, 13.69. I can toggle to a delta max min mode. This tells me my max min delta is 0.008, which is really good. This being fully charged, and these being matched batteries, brand new grade A batteries, this is what I would have expected. And this could also mean that my battery balance features are working. So toggle through mode again. This tells you my highest cell, which is cell 1, and then my lowest cell, which is cell 3, and then all 4 cells together, 13.69. So as you can see, this is super handy to have. So this is what I'm looking for. This is the number I want to see. I want to be able to look at the battery compartment, glance at this number to see that my max min delta is a very small number, like this, 0.005 now. So I'm happy with that. I'm going to figure out where I'm going to mount this once this battery is installed inside the van. So for now, this is going to go in here. And that's it. This battery is done. Now what I'm going to do is I'm going to hook up some load to this to see how much power I can draw out of this. So I've got 2 construction lights that I'm going to plug into an inverter. And the inverter is going to be hooked up to these main positive negative wires. And then we'll just start drawing this battery down to see how many amp hours and watt hours I can pull out of it. Alright, so I'm running this load test, capacity test now inside the house. I've got the inverter, 300 watt inverter hooked up. I'm going through my watt meter, which is the only part that feels a little bit warm, but it's not too warm to the touch. So it's currently drawing about 13 amps, 160 watts, 163 watts, according to this. These are the 2 light bulbs that are running. And using VictronConnect, I'm measuring also with my smart shunt, which is showing that I've drawn almost 3 amps from it already. And it's showing that it's drawing 172 watts here versus 157 watts there. So there's some discrepancy. I don't know where the difference is. I assume that there's some calibration involved either in this little one or my smart shunt. But the voltage is sagged a little bit. As you can see, it's 13.19 volt. 99%. It's now down to 3 amps, so time remaining 19 hours and 30 minutes. Here's the history. We started this 14 minutes ago. Started at 13.77, or a little bit less, I think. Now we're at 13.18. We are about 7 hours into the test, maybe 8 hours into the test. We're at 59% state of charge. We consumed just about 118 amp hours. This is at about the point where my current 225 amp hour AGM batteries would be completely dead right now. But we have a little while to go, 11 more hours to go. The voltage seems a little bit low right now actually for 60%, 13.04 volts the voltage should be a little bit higher. I'm not sure why it's low. Maybe they're just a small voltage sag because there's currently 165 watts of load on it. Okay, I turned the load off just to see what's happening. I bounced back to 13.14 volts, which, if you look at the state of charge by voltage, right between 40 and 70%, which is about right. We're at just under 60%, and we're at 13.14 volts. 13.15, bounce back up a little bit. It'll probably come back up maybe, I don't know, 10 or 20 millivolts more, but probably not much. So I'm just going to keep this load going and turn it back on. You'll see how much it sags when I turn it back on. There it goes. Yeah, it goes right down to 13.06. Alright, welcome back to the super echoey room. I switched the microphone up a little bit, so hopefully this is better. And I'll also switch this up a little. As you can see earlier in the video, that this was feeling a little bit warm through this, but that was actually because of the connectors that were on here. I was using SAE connectors, which are not great. They're not great at handling anything more than a few amps. So I just clipped them off and then soldered them directly to the wire. And these just have XT90s now, which handles it perfectly fine. Because this watt meter is rated for like 300 watts or something, so it should be plenty. I just want to have connectors that can handle it. 35% state of charge left. The voltage is now down to just about 13 volts. Here says 12.97, but over here I'm seeing 13.03, so a little discrepancy there. Calibration situations, I think. And I've used 186 amp hours, drawing at this constant 165 watts pretty much through this inverter. About 5 hours and 39 minutes left. I'm not sure exactly when this BMS is going to cut off. And I don't think I'll reach 0%, but I don't know yet because I've got this battery calibrated at 280 amp hours. I don't think I'm going to get that much, but you never know. I also don't think that BMS is going to allow me to get that much. So we will find out in the next 5 hours or so. If it goes full 5.5 hours, it's going to be midnight, past midnight when it happens. All right, we are now down to 19%. And I wanted to show you this stage because now we've used 231 amp hours. And in one of my other videos, I had done some calculation about using 80% of this battery's capacity because my plan is to charge it no more than 90% and drain it no lower than 10%. So for a 280 amp hour battery, 80% of that capacity would put me at 224 amp hours. And I've surpassed that. I'm now down to the last stretch of this. And as you can see, I'm using more watts now, 207 watts. That's because besides these two lights, I've added this one. That's only a 40 watt bulb because it can only handle 40 watts. Battery, everything's staying cool. I'm not drawing very much. And you can see here 13.03 volts The delta from high to low is 0.039, still pretty low. The high is 3.214, low is 3.183. Oh, voltage just went down to 12.79 for some reason. Well, maybe that's actually what it is. Maybe this this monitor has an error that I have to toggle before it refreshes. So yeah, that matches it better. That matches this now much more closely. It's actually exact. So okay, 12.79. That's the voltage. That's where it's at. So we're getting down to the home stretch. It's going to start dropping voltage pretty quickly now. Well, it is now 11.89 volts, still going. We're 1 amp hour away from pulling the full rated capacity. I guess this could be, let me see. I did have one spec that says the over discharge detect volt is 2.8 plus or minus 0.05 volts. So that means it could be at, if it's going by this, that could be 11.2 volts where it cuts off. Or the over discharge volt release, that's at 3. So I'm not sure exactly which one triggers the cutoff, but apparently it's the lower one because it's still going. 11.87, moments away from hitting my 280 rated capacity. Well, my state of charge meter now is showing 0%. I've hit 280 amp hours, still drawing 195 watts, 16.5 amps. The voltage is now 11.77. I'm really hoping that it shuts off at 11.2 volts because that'll give me a little bit of headroom for the batteries to not be permanently damaged. Because these cells, you don't want to draw them beyond 2.5 volts. That's where some damage could occur. So I'm just going to let it go for a little bit longer, see how much more it can draw. It's either the BMS is going to cut off or the inverter is going to cut off. I'm not sure which one first. But look at that. Over the rated capacity. Even with BMS installed and just your standard Noco Genius 7.2 amp charger. All right, it's 11.42. Now the inverter is complaining. 282.4 amp hours. I'm gonna go ahead and kill it. There we go. 282.4 amp hours. It ended at 11.55 with the inverter complaining about low voltage. It didn't actually trigger the BMS to shut off, but I'm pretty confident that it will shut off. And the fact that I didn't do it, I'm not too upset about it because now I don't have to worry about resetting the BMS once it triggers the low voltage cutoff. 282.4. That's really good. That's over the marketed capacity. I think that's awesome. All right, guys, we're done. Capacity testing is done, and we got 282.4 amp hours out of that battery bank. That's with a starting voltage of 13.77 and a ending voltage of 11.4. And technically the full voltage of this battery is like 14.4, 14.2, but really it's not going to stay there once it gets charged to that capacity. It'll kind of level off at a certain point. So mine leveled off at 13.77. And I used this charger to charge the battery pack, which is, you know, this is not a expensive lab equipment power supply. This is just a run-of-the-mill store-bought Noco Genius G7200, and this has a 12-volt lithium mode on there. So that's what I use to charge. This is what I will be using to charge from shore power. The rest of the time it'll be charged using solar with the Victron solar charge controller. So this is like a real-world charging device. So it represents what it will be actually like when you charge your battery up from shore power. when you have it installed in your van. I'm really happy with that. So this goes to show you, you don't need to have fancy equipment, a lot of advanced scientific instruments to do these tests. I'm in a village in Croatia that only has 100 people. The closest store where I can buy anything is like 30 minutes away. So I just took some time and, did my research, found the supplies, found the parts that I wanted, took some time to get here. Some things took a month and a half to get here from China. Some other things took more time because of customs clearings and all that stuff. But if you want to do it, you can get it done. I've had several questions come in through this build process, and I'm saving them all for a separate video because I think this video is getting kind of long. The goal of this one was to get the whole capacity testing done, which we did. In the next video, I'm going to charge this battery back up. I'm going to take out the existing AGM from the van and install this one in there and show you guys how that process is done and all the different things I have to do to make sure that it's going to work with all the different charging methods that I have in there. Basically, I have to make sure that I have all the settings right for my solar, for my shore power, for my DC to DC charger, and then make sure that the Bluetooth network is connecting properly and talking to each other. So expect that in the next video. If you have any questions about this whatsoever, go ahead and submit them in the comments below. I will collect all of them, and at the end of this full build process, after it's installed in the van and tested and working, I will make a Q&A video to answer all the questions that you guys had and also give you guys a total price breakdown of what I paid to get this battery box built. Because if you buy from the US, your prices will be lower and you get your parts quicker. I hope you guys enjoyed this video. I hope you're enjoying the series. Give us a thumbs up. That really helps with the algorithm. If you haven't subscribed, hit that subscribe button below. And I'll see you guys in the next video.